Okay, I really enjoy these kinds of problems in lesson 63. We are taking the whole square root thing and learning a little bit more. Okay, and there's a few rules we're going to talk about, and that's the product of square roots rule. Product means multiply, right? So timesing square roots rule. Think of it that way. Okay, so here we are. We have, the rule tells us that if you have two things that are multiplied, a radical times a radical, then we can put them under the same radical sign and multiply them together, just like that. Okay, and vice versa. If you have it together already, that's the same as separating them. Okay, so this is a rule that's going to be used a lot in simplifying radicals. Okay, so then here we have square root of 50. We can take factors of 50. In fact, we have the prime factorization of 50 here. If we had done a factor tree, we'd have 2 times 5 times 5. So the reason we want, eventually I'm going to show you why we want to do this, but we have to first learn the building blocks here. Okay, so if we have square root of 50, we can break it down into this, so we can write it this way. Square root of 2 times square root of 5 times square root of 5. Okay, so those are all equivalent. Square root of 135, if we were to do the factor tree, we would see that it, I'm trying to focus a little better for you. Get bigger. Okay. Square root of 135, if we did a factor tree, we'd have 3 times 3 times 3 times 5. Okay, and again, we can separate all those out. So we would have root 3 times root 3, or they say radical 3 times radical 5. Oh, sorry, you can't see it. So that's what we would have there. Okay, so here we are. We're going to try and use these rules to learn how to simplify square roots. Okay, what that means is we're really going to try and take out every perfect square we can. Can you hear the dog in the background? He wants to go outside. Decided to do that while I started videoing, so I apologize. Okay, so we have a square root of 50. And what I like to do is sometimes I tell kids before they start, when they're doing these radicals, is to make a list of all the perfect squares they know. 1 times 1. Oops, can you even see what I did there? 1 times 1. 2 times 2. 3 times 3. 4 times 4. 5 times 5. 36, 49, 64, 81, 100, and so on. These are like your list of magic numbers, okay? Perfect squares. And whenever we get a number or something that we want to simplify, like square root of 25 in this case, or sorry, square root of 50, we are going to use what we know. What perfect squares, from that list that I did over here, what perfect squares go into 50? I found one. I think perfect square. Perfect square is 25 times square root of 2. Does that make sense? Okay. So now that I have perfect square separated out, oh, look at that. That can actually be, we can take a 5 out of that, and now the radical is gone. So we want to take as much out of the radical as we possibly can. So if square root of 25 is 5, there are no perfect squares that are factors of 2. So when we do something like this, here's our final answer. Does that make sense? I enjoy these. Like I said, you take the big number, figure out if there's any perfect squares that go into them. All right, 200. Is there a perfect square that goes into 200? Right now you should be thinking, oh yeah, 100. That's the same as square root of 100 times 2. All right, and now that I have square root of 100, I know a perfect root of that. And square root of 2 cannot be simplified. So we leave it like this, and there is your final answer. So the idea is to get this down as low as we can go and pull out whatever we can. 108, that would be a harder one, because right now I'm thinking I don't really know any perfect squares that go into 108. So I might go do a factor tree and see if I can find any, well, let's go ahead and do a factor tree instead of just telling you that's what I would do. All right, 108. Now what do I know about 108? I do know that's 12 times 9. So if I did 12 times 9, I see that's 3 times 3. So that is a perfect square that goes into 108. But can I think of a bigger one? Let's see. This is, you know, should we do 2? Yeah, we'll do 4 times 3. Oh, I got a bunch of 3s. And that's 2 times 2. Okay. So we might go ahead and say, let's do it this way. So that's helping us break down 108 a little bit. I actually notice that 36 goes into 108 when I look at this, and I'm not sure if you would see that. This is a little bit higher level thinking, so it's okay if you don't. I can see that I've got 2, 2, 3, 3. So what that means is I've got 6, 6, and 3. So that's the same as 6 times 6 times 3. So 36 times 3 equals 108, which tells me, ooh, 36 goes into 108. Here's where I also allow some cheating when we're simplifying radicals. I have 108, and I might go, okay, what are some perfect squares that I know? Let's see if 49 goes in there. Nope, that did not work. 108 divided by 81, that's a perfect square. That doesn't work. 108 divided by 16, that gets used a lot. Nope. 108 divided by 36. Oh, look at that. That worked out perfect. So we just found out that 108 is the same as 36 times 3, which I kind of tried to show here in case you don't have a calculator. Calculator use will get to be a little more common as you move up in math. All right, so 108 is the same as 36, square root of 36 times square root of 3. Okay, so the nice thing about that is square root of 36 is a perfect 6, and there is nothing we can do to simplify square root of 3, and there we go. Okay, these are going to take some practice. This is all new for you. I remember learning this, and I think I had to get a tutor for it because I was pretty lost when it came to this. Once I figured it out, I was kind of frustrated that it was as easy as it was. I'm not sure if it was just presented to me the wrong way or what, but I do remember this being a little bit hard. Okay, now this is something completely different. These are some fractions I want you to memorize, okay? 1/3. I want you to memorize how the fraction can become a decimal without having to do 1 divided by 3. All right? So like this. If we had 1/3, one way to do it is if you had a calculator, 1 divided by 3. 0.33333333. So how would we write that? 0.3 with a bar. Okay? So if 1/3 is 0.3 with a bar, 2/3 is 0.6 with a bar. So these are things to memorize. They should always be in your head. 1/9. That doesn't get used as often, but 1/9, if we did 1 divided by 9, we get 0.1 with a bar. And 1/6 is 0.16 with the bar just over the 6. Okay, I'll show you what I mean if we do it on this. 1 divided by 6. All right, now do you see why they put a 7 here? They rounded. because they can't do infinity on a calculator. So at some point they had to round. So if it goes 6666 to stop, this last number is going to have to round up to a 7. Okay, now you will have only 4 practice problems, and I really want you to go back and use what we did up here and try it down here, and then check your answers in the answer key. All right, that's it for lesson 63. It's a shorter lesson, but pretty meaty new stuff. So take it slow and do your best and call me if you have any problems. Okay?